Welcome back, everybody, to Unit 6. We're going to make a quick change here. This is Lesson 4, so please change that on your papers. These are what we call the rules of exponents. Rules of exponents. Now, this is a really tricky lesson here because you see these are called rules. So the tricky part is that you can apply any rule at any time. So that becomes a little bit tricky because it's not sequential. It's not like I have to apply the zero property rule or this negative property rule. I can apply any of these rules that you're going to learn about today. I can apply any of them at any time as long as you must follow the rule correctly. So that's the key here. The whole objective here is to apply the rules of exponents. And the whole reason is to simplify or evaluate what we call monomials. So monomials is like a single variable term. So a single variable term would look something like this. Let's say I had 1/3, or let's make it 2/3 x squared. So this is a single variable term. It's got different parts. It's got a coefficient right here, coefficient, and it's got a variable, an unknown, and it's got an exponent. So that's an exponent, same word right here. Sorry about that. Exponent. Here's the exponent here. That's going to be kind of the key that we're going to be focusing on. So the monomials contain variables. We just looked at that. Unknowns. That's an unknown. And then we have the rational number. You can see it's written as a fraction. How do we know it's a rational number again? How do we know that? Because rational numbers can be written as fractions. And then we see this word varying powers. Okay, well, this is another word. Powers is another word for an exponent. They're used interchangeably. So when you see the word powers and exponents, it's the same thing. So we're going to look at all these laws. So there's a lot of them. Well, there's not a lot. I have 7 listed here. Some of these are from your book. Some of them are from the internet. So they don't exactly match. Now, you were assigned on Con that any variable taken to the 0 power is equal to the number 1. So let's take a look here. I don't quite see the 0 property listed in here, so this is just something you have to memorize. So let's say I had the number 3 to the 0 power. What does it equal? It doesn't equal 3. What does 3 to the 0 power equal? It equals the number 1. What does 1/2 to the 0 power equal? Doesn't equal 1/2, it equals 1. And we can look at that really simple. It's super easy to understand why if you look at our numbers in the base 10 system. Let's take a look at the numbers 100, 10, 1, 0.1, and 0.01. So 1/10, this is a 10th, and this is a 100th, and this is 10, this is 1, and this is 100. Well, we know that this is 10 times 10, and this is 10 times 1. We'll get back to this one. This is 1/10 is 1 over 10 times 1, and 1 over 100, which is 1 over 10 times 10. So this is 10 squared. 10 to the first, because 10 times 10 is 10 squared. 10 by itself is 10. This is 10 times 1. But if we're seeing that the exponent's going down by 1, we can put 10 to the 0. If we're saying then 10 to the negative 1 and 10 to the negative 2. And we're going to build out this idea of, this is the quotient property right here, that the rule here for this is you can change this negative exponent to a positive exponent if you move it from the numerator. This is in the numerator. It's a numerator numbers. Their equivalent would be, oh, I can change that power from negative to positive if I push it to the denominator. Same thing for this one. If I push this to the denominator, then I can change the negative exponents to positive. And I can do it vice versa. If I push these back into the numerator, I would have 10 to the negative 1 and 10 to the negative 2. So it's just something new, a new way to represent the numbers, but in this base 10 system. That's what exponents are. They're a base system. Okay, let's continue here. So we just covered this negative property. Number 2, the negative property of an exponent. So if the exponent is negative, like in here, notice the entire number's in the numerator. And now we push into the denominator, and you can switch the sign. And the example for this one, if we poke around, look at the likewise situation. This number in the denominator has a negative exponent. Then you bring it to it's in the denominator, we bring it to the numerator, and now you can switch the signs. So if we look at that, where does that one represent? Down here. So we're going to have to go ahead and draw an arrow all the way down for your good example at the bottom. So let's push that here. Draw this arrow right here. A to the negative n equals 1 over n. Let's look at it as a real number. Again, this here, notice it's in the numerator. And now the 1 is in the numerator. We've pushed this entire number into the denominator. And then you can change the sign of the exponent or the power or exponent. So a bit more complicated than anything you've probably ever seen before, and that's fine. Let's take a look at the product property of the exponents. So we have this next rule, the product property. If you have a base number to a power and the same exact base number, what you do is you add the powers together. So let's look at the real life example of this. This is matching with this one right here, so go straight across. And we'll look at the real life example. So notice that the bases are the same. The base numbers, the bases are 2. They're the same. You add the exponents. Okay. Likewise, if you're dividing in that way, the quotient property, the opposite of multiplying is dividing, and the opposite of addition is subtraction. So that's what we're going to do here. Just straight across. If the bases are the same here are the bases, we subtract the exponents because it's the opposite. All right, let's move on. A power raised to a power. So we have this number, b to the m, and then it's raised to a power. Now we're going to multiply. You see this guy? You're going to multiply. So a power raised to a power. You're going to multiply the exponents. Next rule. If you have several terms inside and they're raised to a power, each factor, I should say, instead of terms, each factor gets raised to that power. So you have two numbers multiplying. These guys are multiplying, and they're both raised to the power of m. Okay, so let's see that example. Here is that example. Right here. 2 times 3 is being raised to the 5 power. So both the 2 gets the power and the 3. So each factor is raised to the power. And here's that zero property again, the zero property of exponents. It's given down here. Any number to the 0 power is equal to 1. We did that example too. Which leaves us to some interest, the last. This is not in your book, but you can write square roots as, so square roots could be written as a number to the 1/2 power, which is nice when you do stuff like square root of 4. I could rewrite it as 4 to the 1/2 power. Then I could rewrite 4 as 2 squared to the 1/2 power. And now I'm multiplying power to a power of 2 times 1/2, which is 2 to the 2/2, which equals 2 to the 1st, or 2. So now I know that the square root of 4, I have a proof of it that it's equal to 2. And then any root can be like a cube root. You can rewrite it as a number to a power of that root. So, but it's a fraction power. So that's a little bit more complicated. You can see I can rewrite this cube root of 27 is 27 to the 1/3. I can rewrite 27 as 3 times 3 times 3, or 3 cubed. 3 times a third is 1, so you get 3 to the 1, which equals 3. And that works for any index. That's called an index. That's the root that you're taking it to, and you can write it as a fraction power. So at the bottom of your page, very careful to just point out that the base, when we talk about the base number, it's the number that the exponent here is, that's how many bases are multiplying. The exponent tells you how many bases. The exponent tells you how many times the base multiplies times itself. This is really easy to see. Let's say I had -3 squared. Okay, well that tells me I'm -3 times -3, which equals +9. Now, I could have a different number. Let's say I had -4 cubed, then I would have -4 times -4 times -4, which is -64. Okay, let's take a look at the next. Just a few more examples of kind of a review. The same thing that we just looked at. Here is 2 times 2 times 2 times 2 times 2. That's a lot to write out. Expanded, we call this expanded. And if we want to wrap it up really nice and neat, we use these exponents right here. So this is equivalent to 2 to the 5th power. And that's more examples. You could do it with x's. Instead of writing all these x's out, you could just do x to the 10th. So you get some got it problems. Okay, well, I could evaluate this. The bases are the same. I'm going to add the exponents. So I get 9 to the 5th. I'm not going to calculate it out. A to the 3 plus 2. What am I going to get? A to the 5th. A little more complicated here. These has a power of 1. So what am I'm going to be able to multiply the coefficients together because it's just strictly multiplication. What do I get for the coefficient? Negative 2 times negative 8. Positive 16. What do I do with the m? What is the rule? If the bases are the same, what do I do with the exponents? That's right, I add them together. 16m to the 6th. Okay. All right, so same thing with dividing, but instead of adding here, now we're going to be doing dividing powers. So we're going to do the opposite of adding, which is subtracting. The opposite of adding is what? Is subtraction. So we're going to have these. Bases are the same. What do I get as a result? 5, 7 minus 4, 5 cubed. And you can see up here, here's an example. This is the same example. It's essentially, you're just cross-canceling. 5 to the 7th is 5 times itself 7 times. And then you just go through and start cross-canceling. What do you end up with? 5 cubed. And that's what we got here. Here we have, what do we get? What's the answer here? X to the 10th divided by x cubed. What are you going to get? X 10 minus 3. It only works if the bases are the same. So you have to make sure your bases are the same. So if I had x, let me use something else. W to the, no, don't use W. Let's say I had P to the 5th times x squared, and in the denominator I had P to the 4th. I don't do anything with that x squared. I get P 5 minus 4 times x squared. The x squared isn't affected at all, which equals P times x. Okay, so you can keep going. Now, these numbers in front, 12 divided by 2 is 6. This, you got to put a little 1 there because that's W 5 minus 1. 6W to the 4th. Okay, and we do this for, we could go on and on for all day here. And once you get good at this, you don't have to actually write this step. You can do this stuff in your head. What am I going to get when I divide these numbers? Now, remember, you keep the base. We're dealing with real numbers. So this 3 has to be, you're not dividing the 3s. You're not going to get 1 down here. You're still going to have, we're just working the rule of the bases. I mean the exponents. The exponents are here, 2 and 4. So 4 minus 2 is 2. There's a 1 there. 5 to the 1st, 7 squared. But we don't, when the power is 1, we don't write 1. So you're going to end up with 3 squared times 5 times 7 squared. And if you wanted to multiply these out, you could. You could go 9 times 5 times 49. That's a big number. I'm not going to calculate it. Let's try h really fast. Do it in our head. Okay, what are you going to get? 5 squared, 7 squared, 8 to the 1st. Negative 2 cubed, 3 cubed, 5 cubed. So you're subtracting these exponents because it's division. We're almost wrapping up here. We're going to wrap it up fast. Power to a power. Again, power raised to a power. This is it expanded. If you expanded it out, you'd be applying the addition rule. But instead of having to do that, 4 plus 4 plus 4. What is 4 plus 4 plus 4 plus 4 plus 4? It's 4 times 5. 4 times 5. So you end up multiplying the exponents. Six to the 20th. So we could do that pretty fast. We're going to do power to a power. Power to a power. So what is the result here? What do you get? 2 to the what? 2 to the 10th. You're not adding these because that's different. What is different? 2 to the 5th times 2 squared is not the same as this guy. Not the same. Okay? Here we got w to the 4th. What are you going to get for b? W to the 24. What are you going to get here? Oh, I see a bracket, so I'm going to go one step at a time. 3 squared raised to the 3rd power is going to be 3 to the 6th squared, 3 to the 12th. So a little harder. Always pushing the rigor up a little bit. Power of a product. So here we're almost wrapped up here. That means everything inside gets this cubed. So that cubed, it's a power to a power, but there's multiple terms in here. I mean multiple factors in the parentheses. So we have this this rule that says everything inside the parentheses gets that power. So here we apply the rule. We have 8 to the 1st power, so we're going to be raising these things to the 2nd power. We're multiplying. 8 squared b to the 18th. Here we have 6 to the 1st. 1 times 4, 6 to the 4th. 5 times 4, 20. 11 times 4, 44. Same thing. Now we have a negative number. Let's keep the negative 5 in a parentheses. It's to the 1st power. 1 times 3 is 3. W to the what? 6. Z to the what? 24. And the final page. We know about 0 and negative exponents. Let me see if I can get this just a little bit clearer. 0, anything to the 0 power, what is its value? And now we have negative exponents. So we talked about that at the very, very, very start. Something to the negative power, we can push it to the denominator like that. So we're going to push this to the denominator. We're just going to write it as 1 over, and now we can make it positive. What is that one going to become? 1 over b to the 4th. What's 5 to the 0 power? 1. That's a rule. Anything to the 0 power is 1. And what do we do here? 1 over m cubed. Okay? And then there's more to do here. We could rewrite these as negative exponents, or with negative exponents. So how do we do that? It's in the denominator. Let's push it into the numerator and switch the sign. Oh, let's rewrite this as 1 over 2 squared. Now I can rewrite it under the rule. What does it become? Push it to the numerator. What do I do to the exponent? Negative 2. What do I get here when I put c in the numerator? C to the what? Negative 5. Here is 1 over 3 cubed. Now I want to rewrite it as a negative exponent. 3 to the what? Negative 3. Okay, and then the most complicated, here we have multiplying and dividing with negative exponents. So then the rules can go anywhere. You could change that to a positive exponent. So there's all kinds of different ways to solve it. Bases are the same. It's multiplying, I add the exponents. That's one way to do it. 3 to the negative 6. Or I could rewrite that as 1 over 3 to the 6. Another alternative way to do this would be to go, oh, okay, well that's 3 squared. I can push that into the denominator. And now I could go 3 to the 2 minus 8, and I end up with 3 to the negative 6. which equals 1 over 3 to the 6th. Like I said at the very start, you can apply any rule at any time, but you must follow the rule correctly. And that's what you're seeing here. There's no one way to solve these things. So, for example, here, one thing I could do is I could switch these up. If I could make that b to the 7th and b to the 4th, and then I could go, well, the bases are the same, so I subtract the exponents. B cubed. It's your application. So there's no one particular way to do it right. I could have done b to the negative 4 minus negative 7. Well, that's b to the negative 4 plus 7, or b cubed. As long as I apply the rules, follow the rule, then you're okay. You could do it in any order. And that's the key. So good luck. I know it's a long head puzzle, so thanks for hanging in there with me.